Okay, question 2.3 asks us in heap sort, do we use a min heap or max heap and why? So recall for heap sort, we use a max heap because then we can fill in the array of sorted elements from the back to the front in the same array we use to represent our heap. So what does this exactly mean? Well, let's consider this array here. And this array is like a snapshot of the array in the middle of heap sort. This portion here is our heap, and this portion here in this blue color is the sorted portion. And notice that we can store both the sorted portion and the heap portion in the same array. And this is the heap portion drawn out in the traditional tree diagram. So hopefully this visualization makes it easier to understand why we use a max heap. Okay, so lastly, question 2.4. Question 2.4 asks us to sort the following array using heap sort, given this array 3, 2, 1, 5, 6, 8, 7. So recall that the first step for heap sort is to heapify the array in reverse level order. So I'm gonna have the array down here, and then the heap in tree format up here. So this is our heap, what it looks like. And because we sync in reverse level order, notice how syncing nodes 5, 6, 8, 7 does nothing. However, syncing 2 is going to swap 2 with 6. Syncing 1 is going to swap 1 with 8. And notice how these changes are also reflected in this array down here as well. And lastly, we need to swap, we need to sync 3, which means we need to swap 8 with 3, and then swap 7 with 3. Okay, great. So our array has been heapified now. Now it's time to actually run the heap sort algorithm. So again, this is our array, and let's run through. So recall that we need to pop off the max element, in this case it's 8. We swap it with the last element, in this case it's 3. And then we just sync 3 to its correct position. Once 3 has been sunk to its correct position, we just rinse and repeat. We pop off 7, swap with the last element, 1, and then sync 1 to its correct position. Pop off 6, swap with the last element. In this case, it's 2, right? So 2 is here, we swap it with 6. And then we sync 2 down to its correct position. Pop off 5, swap with the last element, which is 1, and then sync 1 down. Pop off 3, swap with the last element, which was 1, and then sync 1 down to its correct position. And then finally, we pop off 2, swap with the last element, which is 1, sync 1, well, there's nothing really to do there. And then we pop off 1, and we're done. So this is the final array that we should get. Notice how it's in sorted order, in ascending order. And yeah, that's it for question 2. And I'll see you guys soon.